Automotive dealerships and OEMs are aggressively integrating artificial intelligence. They are rolling out chatbots, deploying predictive marketing modules, and embedding machine learning into service. While these surface metrics suggest progress, they mask a structural error in how the technology is being integrated. Traditional software runs on rigid instructions, executing a predefined set of rules. Artificial intelligence functions as a pattern engine that models probability, inferring what is most likely to happen next based on the data it can see and the objectives it is given. Most current strategies involve evaluating and purchasing AI as a series of functional features. Organizations drop predictive models into the CRM, plug recommendation engines into the service platform, and add automated outreach to marketing, keeping existing departmental boundaries intact. In a modern dealership stack, CRM, DMS, and service scheduling exist as distinct blocks. Dropping an AI node into each optimizes individual departments, but the systems remain disconnected. They produce isolated judgments. Service, sales, and marketing generate conflicting models of the exact same customer. The organization improves its individual processes. Sales gets faster, and service throughput increases. Yet the structure prevents any single system from understanding the customer's full lifecycle or seeing the operation as a whole. Deploying intelligent tools into a fragmented system creates local efficiency without generating true organizational intelligence. This accumulation of disconnected AI tools creates a specific compounding operational friction known as coordination debt. Every time an organization adds an isolated AI system, that system produces its own signals, predictions, and recommendations. Because the tools cannot communicate, human operators must manually reconcile the outputs of the sales AI with the service AI to determine the next step. Handling complex cases requires staff to manually extract service recommendations and cross-reference finance constraints by hand. This necessitates invisible manual labor to connect fragmented data. Each new intelligence system increases the intelligence that must be coordinated, choking the network with friction. When mechanical power first entered manufacturing, leaders had to completely rebuild the factory architecture to accommodate the new capability. Simply adding engines to existing craft production workflows was insufficient for the scale of the change. Scaling AI requires building it as a core organizational capability rather than a software add-on. The primary constraint to scaling artificial intelligence in the automotive industry is no longer the computing power or the models. Success now depends on the architectural design of the organization holding it. Transitioning to this architecture requires differentiating between two distinct approaches: reactive AI and agentic AI. Agentic systems continuously monitor live data, observe shifting conditions, and maintain deep awareness of the organizational state over time. Reactive AI waits for a human prompt, searches its isolated database, returns an answer, and stops. It lacks awareness of changing conditions outside its specific function. For an agentic system to function, data must be restructured into a unified organizational memory, rather than being treated as operational exhaust stored for compliance. This unified memory architecture enables semantic retrieval. The system searches for information that is conceptually similar or contextually relevant to a situation, identifying patterns that traditional keyword matching would miss. Look at the difference. A reactive query hits rigid folders and stops if it lacks the exact keyword. Semantic retrieval evaluates a customer situation and instantly connects comparable histories, spanning sales, service, and finance, without being explicitly told what to look for. Without a unified memory architecture, artificial intelligence remains a forgetful chatbot. With it, intelligence becomes an active, continuous participant in dealership operations. Consider a real-world scenario. A customer's vehicle is approaching its warranty expiration, and it requires a major service intervention. In an organization built on tool accumulation, the service AI successfully suggests an appointment time, but the human advisor must then manually hunt through the CRM to check past complaints and open the finance system to see if the customer can upgrade the vehicle. In an organization built on intelligence architecture, an agentic node continuously scans the unified data lake. It detects the approaching warranty expiration on its own without any human prompt. The agent immediately initiates semantic retrieval. It scans historical service records across the entire enterprise and identifies a recurring transmission issue pattern from comparable cases. It then pulls the specific customer's current vehicle equity and financing capacity, automatically assembling this cross-departmental context into a unified brief. This complete brief is routed to the human advisor's interface, preloaded with a strategic outreach recommendation before the advisor ever picks up the phone. The human experience in these two environments is vastly different. In the tool-based organization, staff spend their time executing manual data coordination. In the architected organization, humans spend their time applying professional judgment to systemic intelligence. The true operational blueprint of an AI-driven dealership eliminates manual information gathering, ensuring intelligence flows proactively to the exact point of decision. Shifting from isolated workflows to enterprise-wide awareness requires a framework to measure strategic maturity. The Automotive Intelligence Pyramid defines 7 stages of AI integration. Levels 1 through 3 represent tool accumulation, where intelligence remains localized. The boundary before level 4 is the coordination ceiling. Here, adding isolated intelligence increases organizational friction faster than clarity, causing groups to stall. Breaking through to level 4, connected dealership intelligence, requires systems to stop merely exchanging raw data and begin operating from a shared situational awareness. Organizations often fail here because they deploy intelligent systems faster than they develop human AI literacy and trust. Staff are given complex predictive tools, but are not taught how to collaborate with adaptive systems. Crossing the coordination ceiling requires a complete re-engineering of how human teams and artificial intelligence systems collaborate as a unified entity. Once the coordination ceiling is breached, intelligence scales rapidly from single connected rooftops to multi-rooftop dealer networks and ecosystem intelligence. At the network level, a trend discovered in Toronto instantly reshapes inventory models in Calgary. Zooming out to the OEM level, a two-way intelligence loop forms. Real-time dealership telemetry flows upward, directly informing production and engineering cycles before shortages materialize. In this ecosystem model, continuous system-wide coordination replaces traditional contracts and quarterly forecasts as the primary source of competitive advantage. Every automotive leader faces a strategic choice. You can build your intelligence architecture during the current formation period, or wait and inherit the operational playbooks written by your competitors. This graphic outlines the AI architecture principles, focusing on the 3 central gears: unified intelligence, business integration, and continuous learning. These represent the organizational disciplines required to survive the intelligence age. The pioneers who architect the foundation for system-wide intelligence will define the next decade of the automotive industry.
AI isn't just another tool. It's an intelligence system for your dealership. Learn how at autoagentic.ai.
Or get your free copy of the Automotive Playbook for rebuilding organizations around AI. Also at autoagentic.ai.